Have you heard of the Cybertruck? Of course you have, everyone is aware of it, yet this vehicle is altering the game in a revolutionary way and nobody seems to be discussing it. SpaceX and Tesla's collaboration is generating cost savings and synergies that are just amazing and unmatched by any other automaker. Welcome to this video in which we explore the realm of Tesla's success and its ongoing quest for novel concepts using a first principles approach. In 2015, Tesla hired Charles Kuehmann, a talented alloy specialist with a PhD in material science and engineering who had previously worked at Apple and SpaceX. Before we get started, make sure you subscribe to Tesla Stock News. Kuehmann brought a wealth of experience and information to the table, and Coleman's knowledge has made its way into the Cybertruck in ways that will permanently transform the automobile industry. For now, let's set aside the 8,000-ton gigapress for the Cybertruck's rear body. Yes, it's a huge thing, but that's not what we're discussing today. Instead, we're discussing the one feature of the cyber vehicle that has an indirect effect on the SpaceX Starship. It genuinely demonstrates how revolutionary Tesla is. Tesla's success is based on its core values of innovation, continuous improvement, and application of new concepts. Charles Kuehmann, an alloy specialist who left Apple to join Tesla and SpaceX, is the chief of materials engineering at both firms. It's the same air the company breathes back in 2015. After receiving his PhD in material science and engineering from Northwestern, Kuehmann co-founded Questac, a business that created and marketed a number of novel materials engineering tools, processes, and alloys. Prior to joining Tesla and SpaceX, he served as Apple's head of product design for 3 years. A few months ago, we learned that Tesla had inked a supply deal with Steel Dynamics for the Cybertruck. The EF method, which uses high current electric arcs to melt steel scraps and turn them into liquid steel, is responsible for producing around 25% of the world's steel. According to metal-centered news, Ferris 85 will install and run the largest slitting line in North America at FBI's new factory in Sinton, Texas. The slitter can create slit widths ranging from 8 inches to 85 inches, which is essential for building the Cybertruck's body. Steel Dynamics is building a new electric arc furnace steel mill in Texas that will supply steel to Tesla. To employ its alloy, Tesla will need to develop new production techniques, similar to how it designs its Hardware 3 and Hardware 4 fully self-driving processors internally but outsources their fabrication. With a new stainless steel alloy from the Cybertruck, a similar circumstance occurs. The SDI factory, which is 3 hours from Giga, in Sinton, Texas, Austin, and Texas, are home to the secret to Tesla's supremacy. Elon Musk claims that a stamping press might be broken by the ultra-hard 30x cold-rolled stainless steel unique alloy, which holds the key. Because it cannot be stamped like regular steel, this special alloy is what gives Cybertruck its unusual planar design. Let's examine the specifics. The new steel alloy was first used in the Starship SpaceX spacecraft before being used in the Cybertruck, according to Elon Musk's intriguing revelation in response to VV. According to Elon, Tesla had initially intended to use titanium skins for the Cybertruck because the stainless steel option turned out to be much stronger. However, there is more to this choice than meets the eye. Elon's real goal is to increase demand for the alloys that SpaceX eventually decides on by raising production volume and lowering material costs. This clever approach benefits both SpaceX and Tesla because higher volumes result in lower costs. It is crucial to remember that the need for alloys in space applications is different from that on Earth, where rust inhibition is the primary concern. Despite this difference, alloys must be able to tolerate extremely high temperatures during re-entry into the Earth's atmosphere. As SpaceX continues to experiment with new materials, it wouldn't be shocking to see Tesla adopt the Cybertruck. Tesla's pledge to continuously developing materials is demonstrated by Elon's remark from last summer. Unlike traditional automakers that remain with materials and designs for decades, Tesla is changing alloy composition and forming techniques quickly, so standard naming conventions like 304L will become less relevant. Tesla is fueled by ongoing research and development with an emphasis on basic chemistry to continuously improve and apply innovations for the benefit of the typical user. One of the Cybertruck's outstanding qualities is its incredible resistance to rust, scratches, and dents. Since rust is a bigger issue than most people know, let's examine the 304L and 30X cold rolling alloys in greater detail. Even though I could spend hours discussing this subject, let me give you the main ideas and conclusions when Elon Musk describes stainless steel as ultra-hard compared to some sheet metal. Since strong in terms of strength or yield strength is the proper engineering term, engineers may object. Although Elon knows this, he also recognizes that the typical Tesla enthusiast might not be familiar with the yield strength. The idea of yield stress markings or yield strength, the critical moment when a material begins to undergo plastic deformation, plastic behavior, is the term used to describe a material changing permanently in shape as a result of outside forces operating on it. In essence, yield strength establishes the highest load or upper limit of force that can be applied without permanently deforming or changing the shape. Let's now explore the fascinating history of the 30X and its meaning, which was made possible by Thomas Bradford's investigation. Near the end of 2019, Bradford asked Elon Musk if the 30X referred to the alloy type, with X standing for an unknown variable like 303 or 304, or if he speculated that it actually meant 30 times the hardness. The precise composition was not exactly 303 or 304, but rather an innovative series that experimented with cold pressing multiple times. Elon responded admiringly, acknowledging that it was a great question and revealing that it was a new variant of the 300 series stainless steel that underwent multiple cold working processes depending on the kilotons of pressure applied at the time. The 300 stainless steel series is a member of the genuine alloy family, which is renowned for its affordability, durability, and resistance to corrosion. Elon explained the alloy's intended application as being 3 millimeters thick, or roughly 0.118 inches. The steel in Cybertruck doors are 3 times thicker than the majority of other door panels, according to this thickness comparison. When discussing terms like authentic or martensitive Austin-type stainless steel, of which the Cybertruck's alloys are the part is non-magnetic but can acquire slight magnetic properties through cold working or cold rolling, it is important to note that steel has a crystal structure that can be either face-centered, cubic, or body-sensor cuban. When heated or subsequently cooled, it transitions from one phase of crystalline structure to another. The 300 series includes various types of stainless steel falling under the aesthetic umbrella. Additionally, in a previous tweet, Elon briefly discussed the meaning of the letter L in this context. For example, 304 stainless steel has a maximum carbon content of 0.08%, whereas 304L has a maximum carbon component of 0.03%. Although 304L may be structurally weaker than 304, its lower carbon content proves advantageous. Weld joints are supposed to last over time in corrosive environments and throughout the welding process, taking into account the stainless steel series kinds. Similar to battery chemistries, each offers advantages, disadvantages, and trade-offs. Elon's last indication mentioned the particular series of stainless steel S304L, but it's crucial to remember that this will be a proprietary alloy, meaning that neither SpaceX nor Tesla will use any of the conventional 300 series alloys. While specifics are still unknown, we do know that the alloy will undergo cold rolling is a work hardening and finishing technique that creates thinner and harder steel sheets by compressing hot-rolled steel between a number of power rollers. Contrary to popular opinion, cold-rolled stainless steel is ideal for applications needing superior surface qualities and high-precision strength. Remember how Ferris 85 supplied Tesla with hot-rolled steel? Cold rolling does not involve layering. Instead, its main goal is to maintain tight tolerances, thickness, and flatness while guaranteeing. Musk's real revelation is that this extremely hard 30X steel is difficult to stamp or bend. Instead, it requires a deep score on the inside. This is exactly how the amazing Cybertruck prototype was made, and this is where the magic happens when the body panels are manufactured. Tesla uses a state-of-the-art procedure that reduces the need for shaping procedures. Put an end to conventional stamping. Laser cutting ensures accuracy and effectiveness. My friends, they are game changers. Elon Musk himself demonstrated the Cybertruck's incredible toughness and jaw-dropping footage, showing how the skin-resisted sledgehammer blows at close range and 9mm full metal jacket bullets fired from just 10 meters away. The road ahead is littered with fascinating possibilities like this video, so if you found it informative, consider subscribing for more mind-blowing Tesla material. Keep in mind that your next adventure is waiting for you, and have an amazing day. This is a whole new level of toughness.